All right. So the today's session, in the last class, we have seen how we can work with the Docker containers and how we can execute our tests on grid, which is can configured in the Docker environment. So today we'll see execution part, like how we can run tests using Maven pom.xml and through command prompt and then run that bat file. So we are slowly moving on to the execution part. So far, we have seen design and development of the framework. So this part, development, and so we can keep adding more number of test cases, more number of page object classes, because we have created all utility files and we have created test data files and resources also we have already created, right? So we need to just add some more test cases and some more page object classes. We can keep adding more number of test cases. So there's a continuation process. And later I will add some more test cases. So meanwhile, we will jump into the execution part. In the execution, so far we have executed all our test cases in through test engine.xml, right? So through test, we have created multiple XML files for different purposes because every time the same requirement will not be there. So we have created grouping XML file, parallel testing for another XML file. And for remote execution, we have another XML file. For Docker execution and grid, we have another XML file. So it depends on your requirement. We have to choose the right XML file and we can execute that XML file. Okay. And that XML file, once you created and once you executed, we will able to see the external reports and logs and everything. So all the stuff is already exist now in the framework. So almost 80%, 90% of the framework is done. So only thing is we need to just keep adding more number of test cases and more number of page object classes. So these are the only two things we need to keep adding into the framework, right? So first we have taken two test cases, login and account registration. Then we have built the entire framework. So everything is in place. So now let us move on to the execution part. So the execution will happen multiple ways. Suppose if you are automated your test cases today, some test case your automation is done and you will execute within your Eclipse, right? So then your test case will execute and pass or fail, something will happen. That is your local execution within your QA environment, within your system. You can execute within your Eclipse. That is still fine. But once your test cases got executed and working fine, so you need to make sure those test cases also should be executed remotely in the sense in the CI environment, okay, continuous integration environment. So for that, we need to use a special tool called Maven. So Maven is basically called as a build tool. And through Maven, we will able to build our automation. And later on, we will able to run our tests on Jenkins. So to do that, we should able to run our test cases through pom.xml. Okay. So as in the picture, you can see here, the test engine.xml is a main source from where we will start our execution. So this test engine.xml also we can run through pom.xml. So far we have used pom.xml for what? To adding required dependencies, right? So required dependencies, we have added everything in the pom.xml like Selenium dependency, Apache PO dependency, Log4j dependency, external report dependency. So whatever libraries we required for our project, we have keep on adding all the dependencies in the pom.xml. But now in pom.xml, we have to add some more stuff that is called plugins. In the pom.xml, there are two kinds of entries we have. One is called dependencies. That means we can download required dependency jar files required for our project. Okay. So that is the one purpose. And second one is plugins. So plugins are what? The plugins which we can add to the pom.xml through which we can compile and run our project. Okay, we can compile and run our project. So that we can do by using plugins. So in the pom.xml, we have two types of entries, dependencies and plugins. So what is the purpose of dependencies is we can download the required jar files which are required for our project. And other one is plugins. Plugins, once we added plugins, we can compile and run our project through pom.xml. So this is the only single source through which we can run our project. So far we have run through XML file. So that is still fine, that within your Eclipse. But once you come out from Eclipse, because sometimes we will run the test cases outside of Eclipse. In that case, we need to use pom.xml. So testng.xml, we cannot directly run outside of Eclipse. So first we will run pom.xml. So the pom.xml will execute our testng.xml. The testng.xml internally, whatever test cases we have configured, all the test cases will be executed from the suite. So this is a process. So to run our XML file through pom.xml file, we need to add something called plugins. There are two kinds of plugins which we have. So one is called Maven compiler plugin, and the second one is called Maven Surefire plugin. Maven compiler plugin, Maven Surefire plugin. So Maven compiler plugin is used for compiling the project and code, and then Surefire plugin is used for running your project. So both we need to add into the pom.xml. Okay. So from where we will get these plugins? These are also just like a dependencies. How we have added dependency code, just a small piece of XML. Similarly, Maven compiler and Maven Surefire plugins also we can add to the pom.xml. So go to the Google and search for Maven compiler plugin. And these two plugins also designed by Apache. So you can just go to Apache Maven compiler plugin. And if I go here, this is official documentation they have given for Apache Maven compiler plugin. So this particular tool normally used by DevOps team. So they will have something called build lifecycle. They will create a build from the development. So the developer will check in their code, and by using that code, they will create a builds. For that, they will use this Maven, and this is basically build creation tool. But why we are opting this for automation? Because there are some more important features which are also very much required for our automation. That is the reason we are incorporating Maven tool in our automation. But we are just using 1 or 2% of the Maven in our automation, but actual usage will be done by the DevOps team. Okay, they will use very rigorously the Maven. So in this, if I go back to this goals, okay, in this you can see this. This is called Maven compiler plugin. So from here to here, this is called plugin. And this is, again, we have to put inside the plugins tag, and these plugins should be again part of the plugin management. And this is again part of the build. Okay, build tag we need to specify. Inside the build tag, plugin management, inside this we can see the plugins. So this is a plugin which we need to add into the pom.xml. So let me add that plugin. So I already added to my pom.xml. I'll show you. Go to pom.xml. So far we have only added dependencies part. Okay, nothing. But above the dependencies, before starting the dependencies, we will add one more tag called build tag. So starting tag and this is the ending tag. Inside this plugin management, starting and ending tag. And here this is one plugin, Maven compiler plugin. So from here to here, this is one plugin, Maven compiler plugin. Just we need to copy from their official documentation. And this is Maven Surefire plugin. So if I look at Surefire plugin also, there is their official web page. From there you can get this. So this is Maven Surefire plugin, and you can just go to usage and you can find it here. This is a Maven Surefire plugin. Okay. And in the Surefire plugin, we can also add extra tags where we can specify the whichever XML files we want. Okay, what can we not use plugins without plugin management? No, this is a basic tag actually. So within plugin management, we cannot directly add plugins. So all plugins should be part of the plugin management. That's a hierarchy they have given in their official documentation. So we have to use exactly the similar way. So we should not any modifications in this. So this is a Maven compiler plugin, built-in plugin, which we need to just copy from their website. You can put it here. And then this is another plugin, Maven Surefire plugin. And in this is the additional tag we need to add configuration. Inside the configuration, suit XML files, starting and ending tag. Inside this suit XML file. Here we have to specify whichever XML file we want to execute. XML file in the sense testing.xml files. So we have multiple XML files we have created, right? So whichever XML file we want to execute, that name of the XML file we can just specify here. That's it. So this particular part, the entire thing, plugin management to starting tag to ending tag, everything should be part of the build tag, build starting and ending tag. And this entire build section should be starting before starting the dependencies. Okay, before starting the dependencies, and we put all the dependencies, right? Before starting the dependencies, we need to add this particular build information. That's it. This is simple configuration. Just you can copy paste these things. I just have done from their website itself. So done. So we have updated pom.xml with required dependencies. So these are the two plugins additionally we need to add to the pom.xml. That's it. Now we are able to run our project through pom.xml. So let's see. So here I have put master.xml. So previously when I run master.xml file, so these are the two test cases we'll be executing. We have run the testng.xml files many times earlier. Now the same XML file I want to run through pom.xml. So how to run pom.xml? You can just right click on it. You can see something called Maven. Inside this, you can see not Maven, run as. So you can go to run as option. Inside this, you can see some new stuff here. Earlier we have got testng.xml suite, right? When you run the XML file, like if I go back to the master.xml file, right click run as, you can see testng suite. But this time, when you run pom.xml file, you can just run as, there are multiple options you can find. So these are all called Maven goals. So Maven build, Maven clean, Maven install, Maven test, Maven verify. So these are all Maven goals, means the developers will create a build in the different levels. So for that, they will execute these options. They will use these options for different cycles. So we need only one option from this, that is called Maven test. So we have to run pom.xml as a Maven test. Okay, the build version is what? So this is the build version by default you will get from their website. So if I just go back to this website, and here 3.2.5 they mentioned, the same thing I have copied here. So 3.2, little bit older version, and here 3.11.0. So any latest version you can put here. So this version also you can get it from their official website. Okay. So here, remember, we are not going to create any builds. Okay, that's the development task. We are not going to do any create no builds anything. We are not created any development part, right? So to run our automation test, we need to just add compiler plugin and Surefire plugin. That's it. For that, we need to add these two plugins. We are not creating any builds or anything. So just we have added this build section only to run our automation. That's it. Okay, this is build our automation and execute. Right. So once we have done it, now we can just go to run as Maven test. So this is the option which we have to use, Maven test. So execute. So once you added this build, you need to just update your project once. Now you can see it is started our test cases from pom.xml file. So my tests are started execution. So first test case is executed. Now this is my second test. Done. So my report is got generated. So simple, very simple. Just we need to add two plugins and then we have executed master.xml file. So here at the time after execution, you can see build success. What is this build? Build is nothing but an automation. Okay, so actually this tool is used for development to create a builds, multiple builds. So they will take care of that part. So we are not going to do all those things. So automation perspective, we use this build and plugin management only for execution purpose, only for executing our automation. Okay. So our build is success. So you should get this message. If you get build is success means our automation test cases are successfully executed. So you will get some kind of warning like this. You can just ignore this one now. Okay. So this is how we can execute pom.xml within your Eclipse. So that's the first part. Okay, so if I go back to this step, build is nothing but an execution. You can simply say we are building our project or building our automation. So the terminologies will be different, guys. In the different context, we use a different kind of terminologies. Build is nothing but there are multiple meanings of the build. So here the build is representing a process or a consolidated product. So in the development point of view, build is nothing but a integrated software, because they will create multiple programs. They will write a code. So that code is converted into a packaged format, and that package should be able to install in our system, right? So that package is called as a build. So that is a one meaning. So another meaning of build is, so whatever execution we have done, so once execution is completed, it will show you the build success. That means our execution is successfully done. So that is the meaning of build. So in the different context, we need to take a different meaning from the build. Okay. So the configuration part, there is no any configuration part. Just we need to add this one new tag configuration and specify the XML file. Whichever XML file you want to run, you can just specify that. That's it. It will go and execute. So if you want to see this plugin, you can just go to their official website and you can search for it. They will clearly show you. So go to Maven Surefire plugin and just go to Google and just search for it. And directly you will go to their official documentation, and you can see, go to the goals or usage. So in the goal section, you can see how we can specify this plugin management, or you can say usage also. Go to usage, and here you can see, but they have not put XML file, test injet or XML file, that we put additionally thing. Okay. So configuration name always change compared to XML file name. So configuration names won't change anything. Only this suit XML file, this part here, we will change the XML file. Depends on your requirement. Whichever XML file we want to execute, that XML file name we have to add it here. That's the only change. Rest of the things are exactly the same. We should not change anything. Okay. So this is the first part. So how to run the test using Maven pom.xml file. Okay, good. Now how we can run our project through command prompt. So far we have executed everything only within your Eclipse. Now, if you do not have Eclipse, now I'm coming out from Eclipse without having any IDE. So how can we execute our test cases? How can we execute our project? So for that, we have to install Maven software. So as of now, we are using Maven or not inside of an Eclipse. We are using Maven. Why? Because we are able to create a Maven project. We are able to update pom.xml. We are added dependencies and plugin. Also, we are able to execute pom.xml. How it is possible? All these things because we already have Maven plugin, which is already installed in your Eclipse. Right? By default, whenever you install Eclipse, by default, you will get a Maven software. That is inbuilt software within Eclipse. So that we are able to do all the things. But now we are coming out from Eclipse. I want to run entire project through command prompt or somewhere else or Jenkins. So whatever Maven is already exist in Eclipse, which will not work for us. So now we need to install Maven on operating system level. So the Maven is having two different flavors. One is within our Eclipse, which is available as a extension within your Eclipse that we can get by default along with Eclipse. And we can also install Maven on operating system level. Like if you're using Mac or if you're using Windows, so wherever you want Maven, we can install that explicitly, not within your Eclipse. So far, we have used Maven, which is already exist within your Eclipse by creating Maven project, by creating pom.xml, updating dependencies, configurations, and execution. All those things we have done within your Eclipse using Maven. But once you come out from Eclipse, so that Maven will not work. So we need to install our own Maven on operating system level. So then we will able to run the entire project through command prompt outside of Eclipse. So now we'll see how to install Maven software on operating system. Install Maven. So we'll see how to install Maven on operating system level. I will also provide the steps on Mac, so you guys can try the same step on the Mac operating system. So how to install Maven on operating system? It's very simple. You need to download Maven. I'll show you. Go to this website and you can say download Maven and just go to their official website, download Apache Maven. These are all free and open source softwares. All are developed by Apache Maven itself. Okay, Apache projects. So this is their official website, Apache Maven project. And here, if I go to the download section, here you can see multiple options are available. So in this, we need this binary file. Even if you are working on Mac also, if you are working on Mac, we need to get this one. Okay, tar file, tar.gz. This is the file you have to download if you are working on Mac. If you are working on Windows, you need to get the zip file. So once you click on the zip file, it will download a binary section. So this is the link I'll provide. So I can just provide this link. So from this, you can get it the installer. Okay. So I already downloaded. So let me show you the binary zip file. You can just go to downloads. Here you can see. So this is a zip file which I already downloaded. Here you can see Apache Maven 3.9.6 hyphen bin 3.9.6, which is the latest version I have downloaded. So once you download it, you need to extract this folder into the folder like this. So once you unzip, then you will get another folder like this. And once you open the folder, inside this, you can see another folder called Apache Maven 396. I can open this, you can see some more files. So now what we need to do is, you need to go inside the file. So if you open the folder, you will see the other files. So you can just go to this file, whichever file inside. So just copy this folder directly and put that somewhere else, not in the download section. Keep that in somewhere, C drive, D drive, wherever you want. I'm just going to C drive under program files, and then I kept folder here. When you open the folder, you should able to see all the files directly, not within folder, within another folder. Okay, so if I just directly click on this folder, you will able to see all the bin, boot, configuration, lib, all these things. So just a copy paste. So download the zip file, extract it, and then put that folder inside the program files. You can put anywhere in the C drive or wherever, but all the softwares normally we put inside the program files. Okay, now we put in the program files. That's the first thing. Now, once you get this, we need to get the path till bin folder, copy this path. This is the default path. This is the default location, right? Wherever you kept this folder, go to the folder, copy the path till bin folder. Now we need to configure the path. So we need to configure the Maven path. How to configure it? Simply go to the folder. And if you are Windows, you can just right click on this PC. Go to this PC, just right click on it. Go to properties. And here you can see advanced system settings. Go to advanced system setting. We need to just set the Java, just like a Java path we set, right? Similarly, Maven path we have to set. Go to environment variables. And in the system variable section, you can find path variable and click on edit. Now in this list earlier, we already added Java path here, right? Now we need to just add Maven path. I already added here. So if you want to simply add, click on the new button and just paste it over here, same path. So here I already added the same path. So I'm just trying to remove this. That's it. So once you copy this path, just say okay and say okay, and then close everything, close all the windows. That's it. Very simple. Just download the zip file, extract it, place that folder in somewhere in the C drive program files, and then go to my PC properties environment variable section, and then copy the path till bin folder. Okay. So this is the process of installing the Maven. We don't need to install anything. We need to just do some basic configuration. That's it. Okay. So once you configure this Maven, how we will know whether the Maven is successfully installed or not? So for that, what we need to do is we need to just open the command prompt cmd like this. And in the command prompt, we can execute one command called mvn-version. So this command should show the version whichever Maven we configure. So this is the Maven home path, and this is the current version which we have installed. Okay. And before installing this, we need to have installation of Java also. Make sure you have installed Java on your system. And if you look at Java version, this is a prerequisite because on top of Java, Maven will work. So you should have Java here. At least you need to have 11 plus. from Java 11 onwards, 1.8, 8, 7, these old versions won't work. At least 17 plus 17, 19, 20, 21, 20, latest versions, whichever you have, you can keep with that. Before installing Maven, just check Java version, which version you have, accordingly you can go with this. Okay. So now Maven is successfully installed. So what is the command we have to execute once you have done this? mvn-version. This is the command we have to execute. Where we have to execute, we need to open command prompt. Need to open command prompt and then execute maven.version. So where we need to configure path, we need to configure path in the environment variables. So we need to configure this path in the environment variable. So this is the location. Configure the Maven path in the environment variables. So this is how we need to install Maven at OS level, operating system level. Okay. So if you are working on Mac, I'll show you the steps. I'll put all the steps here. You can just follow on this. So Maven path in Mac. Installation is same. Okay. You need to download the tar file. Keep that folder in somewhere in your Maven, unzip and put in somewhere in the Mac OS. And after that, you can just configure the Maven path in the Mac. These are the sequential commands you have to execute. Because open the terminal and execute this command. Echo $shell. And again in the terminal, go to the VA editor, go to this file, and then press I for inserting, because this will open the editor, text editor. And in the text editor, you need to configure this Maven home like this, and then save the file and then exit. So these are the steps you need to follow. Exit is not a command actually. So after clicking on :WQ, the VI editor will be automatically closed. And then come to the command prompt and then execute this command. So this will show you Maven home path, and this will show you Maven version. So these are the steps you can execute on Mac OS. All right. So now once you have Maven software, so we already verified. So if I go back to the command prompt, so in the command prompt, Maven-version is a command. mvn-version. So this command will show you, sorry, all are lowercase characters. So Maven-version, mvn-version. Done. So this will able to show you the option. So this is how we can install Maven on operating system level. So why we need to install Maven? Why it is needed? Because we are coming out from the Eclipse. So from now, we are not going to run tests on Eclipse. Eclipse, the project is there. So but we are not going to run this bounded XML directly from Eclipse. So we are coming out from Eclipse. So we are executing our project. So now we have installed Maven project. So then how we can execute our project through command prompt. So currently we are already open the command. So now what we need to do is, let's capture the location of the project. Go to project, right click and go to the properties. And here, this is the location where our workspace is there. The project is located. So we need to go to the project, copy this location. So this is our current project location. Project location. Or we can say workspace location, right? So we need to go to this location first. Okay, so we need to go to this location, CD, and specify this. So now once you enter in this location, now currently we are in the project location. So here, if I click on dir Java command, Windows command, so here you can see all the files, your project files, right? So here the pom.xml is also present. Now we want to execute this pom.xml through command prompt. So in Eclipse, what is the command we have executed? So when I say right click, run as Maven test, right? Same command is available here. So mvn test, that's it. mvn test. So there is another command called clean. So that also you can add if you want. Clean test means what? It will automatically clean up the previous execution stuff. Suppose whenever you're executing a project, the unnecessary files will be created in the backend. So if you want to clean up all those files, you can add clean command, and then you can use a test, or else you can directly use test command. If you don't need any cleanup, just you can say mvn test. So this command will automatically find this format XML and will execute automatically. Now just observe, I'm minimizing my Eclipse. So I have minimized my Eclipse. Now I'm running my entire project through command prompt, mvn test. So what we have done for that, we have went to your location, cd, the location or path, and then we have executed mvn test. So press enter. Now you can just observe my tests are executing from the command prompt. See this? So through command prompt, I'm able to execute my test. So how it is possible? Just by installing the Maven software. Same pom.xml, whichever is there inside the project, the same pom.xml is got executed and my tests are successfully passed. And if you look at here again in the command prompt, you can see build success. So this is how we can execute our test cases with it in the command prompt. So in the first level, we have seen through pom.xml within your Eclipse. Now we have executed same pom.xml within command prompt. That means outside of the Eclipse. Now, when I'm trying to execute through command prompt, how many commands I have executed? How many commands I have executed? 2 commands I have executed, right? So first we have to go to cd and then specify the project location. And then another command is what? mvn test. So these are the 2 commands I have executed manually. I've executed these 2 commands manually, right? But I don't want to execute them every time manually. Simply what we can do is we can create one bat file, executable file. And if you're working on Mac, we have to create sh file, shell scripting file. It's very simple. It's make automated. So you can just go to project location, wherever you have project files are there, go there. And in this project location itself, I will create one new file, new, just normally create a normal text document, make it as a run dot, remove the dot txt extension, just put dot bat extension, bat. So are you sure you want to change it? Yes. So now it is a executable file. So it is not a text file. It is Windows batch file. If you are working on Mac, you have to create .sh file. So open the file in the notepad. You can just select this, right click and edit in notepad or edit in notepad++. You can edit like this. Open the file and here, whatever commands we have executed through command prompt, just copy those 2 commands and put inside the run.bat and save the file and close it. Okay, so what is this bat file will do is, this is the executable file. So with single click, everything will be executed. So when I run this bat file, this itself will open the command prompt and that command itself will go to the project location, then execute the pom.xml. So all this stuff will be done by run.bat file. So why we have created this file? To just avoid the manual typing of these commands. If I don't create run.bat file, we just need to open the command prompt manually. We need to go to the location of the project. Then we have to execute this command. All these things we have to do manually. But if you put these 2 commands inside the run.bat file, and now we are able to run this run.bat file, just double click on it. It will automatically open the command prompt. I'm just closing this command prompt. Now just observe the beauty. So when I double click on it, it will automatically start your command prompt like this. You can see it is automatically started and it is automatically went to your project location, executed maven.test command. See, my tests are got executing here. You can see here. Okay, all tests are executed. Then my tests are got passed. So this is the shortest way to execute our commands. So run.bat file we always maintain. So this run.bat file is a crucial one, and pom.xml. So if you want to execute this in Jenkins or somewhere in the CA environment, we always use this pom.xml or run.bat. Okay. So this is the first level of execution. We can run our tests using Maven pom.xml within your Eclipse. And outside of Eclipse, we can execute in these 2 different command prompt and run.bat file is same. Both are same. Only thing is I have put commands manually here. After copying the same commands in the run.bat file, so I have executed run.bat file. Yes. So master suite we configured in the pom.xml. So currently it's executing only master suite. If you want to execute another XML files, you have to do some change here. Okay, in the pom.xml, always you need to configure whichever XML file you want to execute, and that will be done. Okay. So suppose if you want to execute multiple XML files, let's say I have master and grouping. There are two XML files. So then what you can do is you can make another entry like this. So under suite XML files, one suite XML file is master.xml file. Another suite XML file is grouping.xml file. But I don't recommend this because both are having two different purposes. So if you want to put multiple XML files, you can put like this. So all the XML files will be executed. Okay. So the source file of execution is pom.xml file. So from now onwards, everything should be started from pom.xml. So pom.xml file internally will execute XML file, testng.xml file. So let me draw the hierarchy now. So you can just look at this. So the execution will happen like this. First of all, we are executing pom.xml file. And this will go and execute testng XML file. And this will execute our test cases. Our test cases will use page object classes, utility files, test data files, and any other configuration file. So this is the hierarchy of execution, the entire overall framework. So the starting point is pom.xml. And this pom.xml we can execute within your Eclipse. We can execute through command prompt. And tomorrow I will also execute the same pom.xml within your Jenkins. Jenkins is a CA tool that we will discuss later. So the same pom.xml we will execute in everywhere, in all the places. This is a single source. And whichever XML file we want to execute, that you can configure in pom.xml and then do execution. Okay. So everyone is clear so far how we can run our pom.xml within your Eclipse, outside of the Eclipse. Okay. So now the Eclipse is needed only to change some configurations. Like in the configure properties file, we can add some more changes. In XML files, if you want to add more number of test cases, you can add them in pom.xml, testng.xml files. And in pom.xml files, we can add which XML file you want to execute. If you want to do these changes, then you can come to the Eclipse and then you can do the changes. Every time this is required. Okay. This is not one-time job. Changes are always frequently happens. Perfect. So now we are able to run our project in Maven pom.xml file, command prompt, and run that. Perfectly done. So execution is also done. We go back to the framework. So we're able to execute everything perfectly fine. Now execution is completed. Then we will move on to the maintenance part. So maintenance part in the sense, we will push our project in the repositories. And from there, execution will start. So from now, we are going to start the CA part. So this part, Git, GitHub, and Jenkins. So these two, these three tools are part of the CA part. CA is nothing but a continuous integration. Okay. So before moving to this Git, GitHub, and Jenkins, we will understand some process, which is very, very important. And you need to first carefully listen, because if you put some experience, definitely they will ask a lot of questions related to this particular concept. So now let us discuss something about what is CI and how things will happen in the CI environment, and where we will use Git, where we will use GitHub, what is there, and actually how developers and testers and DevOps team will collaborate each other, how the project makes things. All these things we need to understand first. So before moving on to the last step, so how to push the code GitHub repository and run Jenkins. Before doing this, we will try to understand the process. Okay. So let me minimize this. Let me just explain the process part. Okay, just a second. Okay, so let me capture the image. Yeah. So just try to understand the process first, and then we will discuss about Git, GitHub, but other things, Jenkins. So if I look at this picture, the mainly three sections you can see. There are three teams are there. So here this is our QA or testing, and the other side we have a dev team. Okay, and this is a DevOps team. These are the main three teams, technical teams involved in the project, entire project. Okay, so now if I look at the development part, we'll start from the development actually, because before starting the testing, development will start. So if you look at the development perspective, let's say there are multiple developers are working on multiple features which are belongs to same project. So there is one project which is having multiple features, right? So every feature is assigned to one particular developer. So multiple developers will work on multiple features. Sometimes if the feature is very complex, then multiple developers will be assigned to the single feature. So for now, let's assume there are multiple developers. So he is first developer, second and third developer, and they're having their own workspaces. Okay, they will having their own code and their own workspaces, their local systems. They are their local laptops are their own systems. And every individual developer is having their own local repository. Repository is nothing but we can maintain all the files in the repository. We can maintain the files, which is basically also called as version control system. So every individual having their own local repositories. So Git is a software which is acting as a local repository. So if you have this software, we can create our local repository along with the workspace. Workspace in the sense working directory. Wherever you are creating the files, modifying the code, updating the code, all these things we will do within the workspace. And upon top of the workspace, we have a local repository. Every individual is having local repositories in their own systems. And these local repositories we will create using Git software. By using Git software, we will create a local repositories. So at the end of the day, whatever the code they have created in their workspace, they have to commit their code into their local repositories. Every individual, they have to do it on day-to-day basis. So throughout the day, whatever code they have newly implemented, whatever the changes they have done, whatever updations, modifications they have done, at the end of the day, they have to make sure those changes should be part of their local repositories. That's the first thing. And once the changes are done in the local repositories, they have to push their code into GitHub repository, because they are working in different features. But ultimately, all those features are belongs to one single project. So then finally what happens? Every individual code from their Git repositories, from their local repositories, they will push their code into remote repository. This is called remote repository or global repository or common repository. So here the full code will be available. All the code, whatever the multiple developers are created, the entire code will be available in one single place. That is called GitHub repository. So Git is acting as a local repository, which is available in your local machines. GitHub is acting as a remote repository, which we can access through URL, which is a website. So from there, we will able to access. So this GitHub repository is a common across all the team members. Everybody is able to access the GitHub repository. And local repositories are individual. Every individual is having their own local repositories. So let's say developer 1 local repository cannot be accessed by developer 2 local repository. But everybody will able to access everything from the remote repository. Okay. So from the development perspective, what will happen is every day they will develop something. And whatever the code they develop, they have to make sure they put in the local repositories first. That process is called committing. Commit. This is a technical term. They will commit their entire code in the local repositories. And once the code is pushed to local repositories, then they committed to local repositories, then they will send them to remote repository. Here we call it as a push. Push. So commit and then push. Push is nothing but what? Sharing the files from the local repository to remote repository. That process is called push. Sharing the files from workspace to Git repository is called commit and push. And this activity will be done every day. Every day. They will put some cutoff time. Let's say 5 p.m. is a cutoff time. And throughout the day, they will work 9 to 5. And sharply at 5 p.m., they will commit the code in the local repositories. From there, they will push the code into GitHub repository. Sharply at 5 p.m., there is some cutoff time. By the time, the entire code will be available in the GitHub repository. That's the step number 5. Now, once the code is available in the exactly 5 p.m. in the GitHub repository, then DevOps process will start. So what DevOps team will do is, there are main 3 responsibilities. One is the build creation. They will run our automation and build certification. So these are the 3 main activities done by the DevOps. So what is build creation? How they will create a build? They will create the build by using Maven tool itself. That's the reason I'm telling you the before. Maven is a build tool which is used by the DevOps. They will compile the code, they will run the code, they will test the code, they will package it, they will install it. These are all called Maven goals. And they will perform it their individual in their environment. That is called build creation. And by taking the code from the GitHub repositories after 5 p.m., by taking the latest code from the GitHub repository, they will do all these activities. And to do these activities, they do automation. So that is called process automation. So they don't do all these things manually. The build creation automatically happens through automation. Run automation also will automatically happen. Build certification is also automatically happen. So to do these activities, they will create their own automation stuff. That is process automation. They will set up the infrastructure like that. Okay. And once the build is created, they have run the automation. From where they will run the automation? Parallelly, our testing also will do the team. Testing people also will do the same thing. So our code, automation code is available in the workspaces. At the end of the day, we have to commit our code in the local Git repositories. And at the end of the day, once you committed the code in the Git repository, from there again we will push it into the remote repositories. Now all the automation code is available in our remote repositories. So in the first step, they will create the build by taking the code from the dev GitHub repository. And second step, they will run our automation by taking our automation script from our own testing GitHub repositories. And once the automation is executed, then build will be certified. This is the process. Continuously will happen. So sharply at 5 p.m., the code check-in should happen from the development side. And throughout the night, the build creation, run our automation, build certification will happen. The next day morning, around 9 a.m., by the time you reach to office, the build will be certified by the DevOps team. And that build we will download in the QA environment and we will continue further testing. So this cycle will happen continuously, day by day. So that means every day you will get a new build. Sometimes every 2 days you will get one new build like this. So that's the reason we call this a nightly builds. This is a technical term. Nightly builds, because throughout the night, the DevOps team will do this particular process. By the time when you come to the next day morning, we will have a build which is certified by the DevOps team. So that build we will download in the QA environment, then we will continue the testing. So this is the process. So if you look at this entire process, where exactly the Git, whatever the development will do, same thing we will do from the QA side also. But what is a major difference here is the development will develop the code for our application. But here we will develop our automation script for our testing purpose. Okay, but initial days, initial builds, we do not have a automation stuff, right? But after 2 to 3 builds, we will get ready with some automation script. Today we have automated 5 test cases, every individual, then pull those changes in the remote repository. So the same night, these test cases will be executed in Jenkins by DevOps. And the next day, I can add another 5 test cases. Then 10 test cases will be pushed to the GitHub repository. Then the next day night, 10 test cases will be executed on the automation. So most of the times, sanity test cases will be executed
during the night itself. The basic functionality test will be done within the DevOps environment itself. Because if the basic sanity is working fine, then only build certification will happen. Build will be certified. Otherwise, build will be rejected here itself if there is a problem. So they will create the build through Maven tool, and they will run our automation from the GitHub repository using Jenkins tool. So these are the two tools majorly they will use in their environment. Maven will be used to create the build. Jenkins is a tool they will use for running automation. Even this process is also we can do within Jenkins. Jenkins is a single tool in which we can do everything. Build creation, run automation, certification, everything will happen within Jenkins itself. But within the Jenkins, Maven will work. Okay. So this is the process, the entire process. Okay, I'll come to that Git part. Just hold on. So everybody's understood the process so far, what I have told you here. I'm not going to explain anything about pull, merge, all those things. We will discuss that later. They are advanced concepts. First, we will understand the basic concept, very, very basic stuff. Without understanding the basic, we cannot directly jump into advanced stuff. So we'll try to understand basic first. So how things will work actually in the real-time environment, how exactly dev works, how exactly QA work, how exactly the DevOps team work, what is a DevOps responsible. So this is a structure, this is the process. Okay, so now let us come to this part. So we don't bother about this part, DevOps and dev part. We will focus on this part. Okay, this is our responsibility. So as a tester, what is our main responsibility is, we need to make sure at the end of the day, whatever code or whatever changes we have done in the workspace, those changes should be part of the local repository that is called commit. From there, we will push our code to remote repository. So these are the two activities. Every day we will do it. And once the code is available in the GitHub repository, the same project code will be pulled inside the Jenkins, and Jenkins will run the automation. So every day this task will happen. So Jenkins will every day will get the latest code from the GitHub repository. Today we have pushed 5 test cases. Then in that same night, Jenkins will execute only 5 test cases. Next day I pushed 10 test cases. Totally 5 plus 10, 15 test cases. The next day night, Jenkins will execute 15 test cases. So Jenkins will pull the code, latest code from the GitHub on day-to-day basis. And once it is pulled the latest code, it will run the automation within your Jenkins. Okay. So this is our area. So this part we have to take care. How to commit our code in the local repositories. After that, how to push our code in the remote repositories, and how we can configure this GitHub project inside the Jenkins, how Jenkins will execute our GitHub project. That also we need to do our own configuration. So this part we will take care. And rest of the part is not in our scope. That is all comes under DevOps and development part. Okay. So now we will see how we can do these activities step by step. So what are the prerequisites? So to work with the local repositories and remote repositories, we need to have two tools. So they are the prerequisites. So what are the prerequisites? First, we need to install Git software. Git installation is required. Git is a local. By using Git, we can create a local repository. So we need to install Git. Second is we need to create an account with GitHub. Create an account with GitHub. So these are the two prerequisites we need to have. So because to create a local repository, we need to have a Git software. This is a standalone software which we need to download and install, which is a freely available. And we need to create an account with GitHub. GitHub is a website. Okay, so if I go back to, so I'm opening the another browser. So here, just type GitHub, and you will see the GitHub software. This is the official website. So you need to log into this. This is called GitHub application, web application, in which we will create a remote repositories. And by using Git, we will create a local repository. Then we will attach both local and remote repository will communicate each other. Okay. So if you look at the workflow, Okay. So first we need to have a Git installation. Then we need to create an account with the GitHub. So let's see how we can do this. So how we can install the Git software. So why we need a Git? Because we want to create our own local repositories. So I will share a small document how we can install the Git so we can follow this. So Git installation. So this is the latest documentation I have created yesterday. So you guys can follow this document. You can install. It's very simple, straightforward. So you can just go to the URL, download Git. You can say download Git, and which is available for all the operating systems. So you can simply say download Git. In the Mac also, it is the same process. Go to Git downloads, and here you can see Mac, Windows, Linux. All three operating systems it is supported. If you are working on Mac, you can just download Mac OS. Working on Windows, then you click on the Windows. It will download. You can click on the Windows. It will go to another page, and from here you can download. You need to download standalone installer. In the standalone, you can see this one, 64-bit. So most of the times, all operating systems are 64-bit nowadays. You can just click on this link. It will start downloading the Git software. So I already downloaded. So once it is downloaded, you can go to the download section. You can see this icon. This is the Git software icon. So now we need to double click on this. It will start installing the Git software. So I have captured all the screenshots step by step. So I'll show you here. You can just go through this. So this is the page you will landed. And if I just click on Windows or Mac, you will get the installer like this. And once you click on installer, it will start installation. It will go through long process. There are multiple screens you can see, but all of them, you can just have a default option. You can just say continue. So once you get a screen, click on the next button. Then you go to another screen. It will show you the location where exactly the Git is got installed. Click on the next. By default location is program files and Git. Then click on the next. And then let it be the default option. You don't need to select anything here. By default, these options are selected. Just click on the next button, and then it will give you some alias name called Git. Then click on the next. Then again, click on the next. Don't select any options. Let it be all the default options. Then click on the next. And again, one more screen you will get. Again, click on the next. And one more screen. Click on the next. So like this, you will get multiple, approximately 10 to 11 screens you will get like this. So the first option is automatically selected. Then click on the next. And again, click on the next. Again, click on this first option. Click on the next. And here, click on this. And then click on the next. Once it is done, again, one more screen. Click on the next. And 13th screen, Git Credential Manager. Click on the next. And then again, 14 screens. Enable file system caching. Click on the next. And then here, no need to select any option. Click on install. So till now, we have set only configuration. So once you click on install button here, 15th screen, it will start installation process like this. It will take some time, 1 or 2 minutes it will take. So once this process is completed, then you will see the Git setup widget like this. It is completed successfully. And then click on the finish. Okay, once it is done, your Git installation is successful. And after successfully Git installation, how we will know whether Git is successfully installed or not? So you will get a Git command prompt. So suppose wherever you just right click on your desktop or any folder or anywhere, when you right click on here, you can see some option called Git bash or Git GUI. These options additionally you will get. Wherever you do right click, you will get these options. And when you open this command prompt, this is called Git command prompt. This is a special prompt actually. This is Git related command prompt. All the Linux and Unix commands we can execute here. So this is Git command prompt. And here you can see Git hyphen version. No, the command is different. So what is the command? Git hyphen version. Git hyphen version. So this command will give you what is the latest Git version you have installed. So this is how we can simply install the Git software. So this is the Git command prompt. So all Git commands we have to execute only in this command prompt. So not in the Windows command prompt or any other terminals. Only in this command prompt, Git command prompt, we can execute all the Git related commands. Okay. So this is simple document I will share. just go to step by step and try to download and install Git software. So that is the first prerequisite. So Git installation is required. And second one is we need to create an account with the GitHub account. So GitHub. So you need to go to GitHub. So you need to go to. So even in the Git, in the Mac also, you can see the same kind of a terminal. Okay, I'll show you that later. So for now, just follow this. Okay, so I can say search for GitHub account. So we need to create our own account. So go to create an account. So this is the URL you will get. So go to this URL and create your own account. See, most of the times in the real-time environment, we don't prefer Mac for development as well as the testing, guys. Most of the times, 90% of the times we use only Windows. So mostly MacBooks will be used by the management or leads because they don't do any technical stuff, right? So technical people, most of the times they will prefer Windows. So that's the reason I mostly show you everything on Windows instead of Mac. But alternatives are there. In the Mac also we can do all this stuff, but you need to do some kind of research for few things because I have not explored everything in the Mac. But few things I have already explored, so I can share that information. All right, so we need to go to this URL to create GitHub account. Okay, so how we can create a new account? You can just go and fill all the information. So your email address, suppose after filling some email address like this, click on continue, then another field will be appear. Okay, so you can just give something, click on continue, then it will give you another one. So give some password, clicking on continue. So like this, it will ask you all the fields one by one. So fill all the fields and create your own account. So everybody should have a GitHub account. This is mandatory, guys. Everyone, every technical guy should have a GitHub account because tomorrow, whatever you practice you have done, whatever projects you have completed, maintain everything in the GitHub repositories because that will be useful just like a proof. Suppose if you go for an interview, so if you want to project your work or if you want to project your task, you can provide your GitHub URL to the interviewer. So they can check your work. That is only the proof you can have. Just putting the resume, projects, everything, that will not be a proof, right? So if you share your GitHub account URL to other people, so they can look at your code. So it will be very, very helpful. And this is mandatory. Everyone should have a GitHub account. So create your own account in the GitHub repository. Okay. So once you create your own account, then I will log into a GitHub account. So I already created my GitHub account. So let me log into my GitHub. So github.com. And I already logged in. So I can see my dashboard here. Go to the dashboard. Okay, so this is my dashboard page. And if you want to see what are the repositories I already created earlier, so go to your profile and you can see your repositories. Click on your repositories. And here you can see all the repositories, remote repository, which I already created previously. Okay, so this is a GitHub account. So you need to have this GitHub account ready with you. Okay, so these are the two prerequisites. Once we need to install Git in your local to create your local repositories. And to create your remote repositories, we need to have an account with the GitHub. In the GitHub itself, we will create a remote repositories. By using Git, we will create a local repositories. Okay, so far everybody is clear how we can do this. So this is the first step, prerequisites, Git and GitHub. So Git we have installed, GitHub account also we created. So now we will see the workflow. This is the most important workflow of Git and GitHub. Git and GitHub workflow. So this is the workflow on day-to-day basis. We all do it. So as soon as your project is ready, as soon as you have done something in your project. So in my project, I have created some test cases and I have added some test cases or I have modified something or I have deleted something. So the changes are commonly happen on day-to-day basis. Okay. So we need to make sure these changes should be part of your local repository. And also the same changes should be part of your remote repository. Because as per the process, our Jenkins will pull the code from what? GitHub repositories. So as an individual tester, we need to commit our code in the Git repository, From there, we will push our code into the GitHub repository. And from the GitHub repository, Jenkins will pull the code and will execute. And the same process done by every individual in the team. So let's say if 5 people are working on the testing automation, 5 people are doing the same thing. And the GitHub repository, the final code will be available. Finally, merged code will be available in the GitHub repository, consolidated code. And that will be executed by Jenkins. Okay. So now our task is whatever the project files are there in the workspace, we will commit them into local repository. From there, we will push it into the remote repository. So this is the process. And to do the process, we have to execute certain number of commands. So what are the commands we want to execute? So let me share the workflow document. So this is the process. See the picture. So first we are here, working directory. Working directory is nothing but workspace. So whatever is there in your Eclipse, this is called workspace. Currently, the project is got created inside the workspace. Okay, so inside the workspace, whatever files are available, we can call them as untracked files. The files which are exist in the workspace are called untracked files. Okay, and these files we have to commit into local repository. Local repository means Git repository. And in between these two, there is another thing called staging, which is also called indexing area. So we will add all the files from working directory to staging. And then we will commit them into Git repository. So why the staging area is present here in between our workspace and our Git repository? Because suppose by mistake, if we added all the files to staging, we can recover those files and we can still modify it. Okay, by mistake, if we added all the files to staging, again, we can get back those changes and we can recover it. But once you committed your files into the local repository, still you have somehow a control. Still we can reset. But once you committed files into remote repository, you don't have much control on this. Okay. So staging area, we will have a full-fledged control. So first we will add all the files from the working directory to staging area. So once the files are sent to the staging area, we can call them as a tracked files. Tracked files. From the staging, we will commit the same changes to the Git repository, which is our local repository. Then we can call them as a committed files. So if our files are present in the working directory, they are called untracked files. Once the files are added to the staging, we can call them as a tracked files. Once they committed to the local repository, we call as a committed files. Once you push them into remote repository, we can call them as a remote files. This is the process. Now this process we can achieve by executing a sequence of commands. So to add our files to the staging, we use one command called add command. And from staging to Git repository, we will use one more command called commit command. From Git repository to remote repository, we will use another command called push command. Add, commit, and push. These are the 3 commands we frequently execute. Add, commit, and push. But apart from these 3 commands, there are few more commands are there for creating the repository, for checking the status of the file, remove the repositories. We have some more additional commands are there. So we will discuss this. So this is a sequential part. So first step is we need to create a new local repository. Git is just a software. We still not created any repository. Okay. So how to create a local repository is by using git init command. So let's create a local repository. Like I minimize everything. Where we want to create local repository, same location. Wherever our workspace is there, go to the same location. And here we have to create our local repository. How to create? You can just open the git command prompt here itself. Show more options. Open the git bash. So you will see the git command prompt here. So if I look at here, currently you are in the project location. You are in the project location, right? So now I want to execute all the git commands here. right? So CLS. So here I'll execute all the commands. So the first command in the Git is what? Git init. So what this command will do? This command will create new repository. So I'll execute all the sequence. Instead of sharing the document, I will write all the commands here. So workflow, this is my round one. So what is the first command? We need to create our local repository. What is the command? Git init. So what this init will do? It will create new local repository. Create a new local repository. This is only one time job. Okay, we will create local repository only one for one project. So git init is a command. So let's go and execute. Git init. I'm executing. Press enter. Now what is saying? Initialized empty Git repository and the repository URL it is generated. It is created empty local repository. Can we see where this repository is got created? In the same location, the repository is always having .git is an extension. .git is nothing but a dot is representing hidden. If I go back to the project location one more time, here, are we seeing here .git extension anywhere? No, we are not able to see because that is a virtual. That is a virtual repository because physically we cannot see. If you want to see that, you can go back here and you can view it. Okay. Go to the view options and here you can select hidden files. Go to the view and here you can see hidden files and folders. Show hidden files and folders. Say okay. Now here you can see .git. So currently it is empty. Nothing you can see here. Okay, because this is a virtual, we will always make it as a hidden only. So we don't need to do anything with that. So I can just go to the show and hidden items. I'm just disabling this. Okay. So Git is got created. So we created the local repository. That's the first step. Now, once you created a local repository, then what we need to do? First time, whenever you create a new local repository, we have to provide the user details to this local repository. Why? Because suppose if you're doing some commits or if you're doing some push operations, how we will know who is doing those actions? So the Git should know your information. So for that, we need to provide some information to the Git software. So this is also one-time job. So provide user information to the Git repository. How we can provide? By using these two commands. Git config -- global user.name. Here you provide your email username and here you provide your email address. So these are the two commands. Only first time you have to execute. Whenever you create a new local repository, first time you have to execute this command. Only one time. Only one time. In the same Git command prompt, you can paste it over here. And here you can change your name. Okay. And once executed this command, it will come out and execute one more command, user.email. These are all one-time command. So here I'm providing the email address, whichever I'm using to sign up in GitHub repository, because the Git will remember your name and your email address. So whatever the changes have done, all the changes will be done by using your name itself. So executed. So two commands are executed. So this is a second step. We provided all the user information to the Git repository. And now actual workflow will start. So what is the workflow here is we need to first add all the files to the staging. And from there, we will again commit to the committed file. And before that, we also have one more command called status. When I say git status command. So what the status command will do is it will show you untracked files. When I execute the status, it will show you whatever files are available. So you can see untracked files. Untracked files means what? All the files changes are still there in our working directory itself. Still, we have not added to staging. Still, we have not committed to the local repository. So red color is showing. Red color means still they are there in our local workspace itself. So untracked files. So now we need to add all these files to the staging. So how we can add? We have one more command called git add. And there are multiple options here. When I say -a, this command will add all the folders along with all the files will be to the will be added to the staging. Suppose sometimes we don't need to add all the files. I want to add a specific file. Suppose I want to add this master.xml specific file. Then here instead of -a, you can specify file name like this. Whichever file you want to add, you can specify this. Suppose if you want to add only a particular folder, not all the files, then you can specify the folder name. Suppose reports is my folder. You can say reports. So if you want to add a specific file, you can add, or if you want to add all the files, you can say -a. If you want to add a specific folder, specify the folder name. Okay. So the add command is having multiple flavors. So I will add this here in the notepad. Third step, adding files or folders to the staging, which is also called indexing area. So what are the commands? Git add -a, which will add all the files and folders to the staging. And if you want to add specific file name, you can specify. Suppose I want to add similar type of files to the staging. Suppose all the Java files I want to add. Then star is the extension, star is a file name representing file name, dot extension should be Java. So this command will add all Java files to your your staging. Then if you want to add only specific folder, you can specify the folder. So this is the different flavors of add command. Now, as per our requirement, I want to add all the files as of now. So I'm executing this command, git add -a. So once you executed this command, just observe all the changes I've added to the staging. Now again, if you type git status command, git status, just observe every file, every folder is turned into green color. Everything is in green. It will show you folders along with the files and everything. Green is nothing but they are tracked. If I look at here, again, documentation, once we add it to the staging, the files become tracked files. Okay. So now changes are added to the staging. So from the staging, we have to commit those changes into local repository. So that's the next step. How we can commit the changes into local repository? We have another command to execute. Fourth command, git commit -m and specify the commit message. Because whenever you're committing some change, you have to tell what is the change you are committing. What are the new change you have done? So that we need to put in the comment. That's mandatory. So whatever the files we have added to the staging, we will again add the same changes to the local repository. For that, we have to execute this command. So let me go and execute this command. So first, the files are in red color because they are the untracked files. So once you add it to the staging, they become the tracked files, turn into green color. Now I'm committing them into local repository. How we can do? Git commit -m. In the double quotations, I can put commit message. I can say this is my first commit. Okay, so just press enter. So now all the files are turned into white color. So white color is nothing but all the files are successfully added to the local repository. And if you type status command, git status, see, no branch on branch master, nothing to commit. That means there are no files, there are no tracked files, there are no untracked files. All the files are attached to the local repository. All the changes are there in the local repository. So now if you go back to the picture, we have done this process. We have added all the files to staging. Then we have committed all the files to the local repository. Now all the changes are there in the local repository. Okay. So we have added all the files to staging from there to Git, right? But can we see all the files in the working directory now? Can we see the files here? Still the files are there. Those files will not go anywhere. The Eclipse files are there. Only the changes, one copy will be added. Okay, one copy will be added to the staging. And the same copy I will add it to the Git repository. So now all the files are there in my local repository. Now what is the final action? We need to push these files to the remote repository, which is GitHub repository. Now, how we can make it happen? By using push command. Okay. So now we'll see. So before pushing this before pushing to our local to remote, we need to combine these two. Okay, because as of now we have a local repository and remote repository, so we have not combined them. We need to establish the connection between these two first, then only we will able to push it. So how to establish the connection? So first go to your remote repository. So here we will create our own remote repository URL. So how to create our remote repositories? You can click on the new button here, and there are multiple places you can do this. Suppose you can go here to our profile picture, and you can use this your repositories, and you will get this screen. And here you can use new, or else what you can do, you can just go to the overview section here. From the overview also you can find I think somewhere you can see the new repository you can create. There are multiple places are there. Okay, so let me use this one. So I'm clicking on new, and then it will ask you the repository name. So whatever name you have given to the project, just try to give the same name to the repository also. Okay, same name I'm giving. Okay, so if you are provided this name, if it is available, it will show you available. Suppose if the same name you have given to some other repository with your account, so it will not allow you. So this is a new name I'm giving, and then make it as a public by default, and then click on the create repository. That's it. So it will create a new empty remote repository. So as soon as you created, it will generate one URL like this. So you need to copy this. This is the most important. Okay, so we need to create a new remote repository URL. So this URL we have to use to link your local repository with your remote repository. So how to link with the, suppose if you forget to see this page, again you will go to your profile repository section. Okay, you can see that here. So how to extract the link? Again, click on it, and it will show you this page, and here you can capture this. So this URL is must. Okay, so this URL is must. So in the first step, create an account with GitHub and create remote repository. Then capture URL. So I put the step at the beginning itself so that you will be aware of this. Okay, this we have created an account with this. Okay, and then this URL is for account creation, login creation, and this is for uh, repository URL. So once you created your account with the GitHub, then you will able to create a repository URL. So this will be very, very useful. With this URL only, we have to link our local repository with your remote repository. Okay. Now, so let's go and link with them. So how to link with them? So to link this, we need to execute one command. This is also one-time job. Fifth command. This we have to do only one time. So we have to connect local repository with a remote repository. One-time job. Every time you don't need to do this command. I will show you multiple rounds of execution. Don't worry. So what is the URL we captured here is this one, right? So capture this remote URL and put it in here. That's it. This is the command: git remote add origin, and then specify the GitHub URL. So this command will connect your local repository with your remote repository. So let's copy this command, go back to the Git repository, Git command prompt, and paste it over here. That's it. Once you executed this, it is connected. Okay. So once you connected, now we can push the files. So we can push all the files from the Git repository to remote file. How to push it? So as of now, if you look at the remote repository, I don't have anything. It is an empty repository. I don't see any files here. Now let us push the files into from local to remote repository. So how to push them? We have to execute one more command for push. Very simple command. Last command. Push the code into remote repository. The command is git push origin master. Git push origin master. So this is the command we have to execute. So let me execute. Okay. So git push origin master. So this command will push all the code from local repository to remote repository. We already established the connection also, right? So just execute. So once it is executed, just observe. It will show you a new window like this. First time it will show you window because we need to enter the login details. GitHub sign in. So sign in with your browser or token, it is also asking. There are two options are provided. So I'm just signing. These are the new options are provided. So you can use a token option most of the times instead of using browser and device, because the browser and device, if you keep changing, so this may not work properly. So just try to use a token. Means we can create our own token also. I'll show you both. Okay. So first, let us see the token. How we can create this token is just go to repository. One, we need to take one token, but we need to create one token. So how to create a token is simple flow. Go to here, profile, go to settings, and in the settings, go to developer settings here. Okay. In the developer settings, you can see personal access tokens. So you can expand this and you can say tokens classic. Select this tokens classics. And here I already created a few tokens earlier, so they have already expired. Now I'm going to create a new token. So for that, what you can do is you can see generate a new token. So use this option, generate a new token. So it is asking my password. So let me provide my GitHub password. I say confirm. Okay, now it is asking for some node. So if you want to provide, so testing token. So I'm just providing some name. And how much days you want this token, you can provide expiration 30 days or no expiration, anything. And here there are some privileges you need to select. So we need to handle the repositories and mainly administrator, right? So we need administrator. So go to admin.org and delete repository user, and some privileges are required. So I'm just selecting some of the privileges here, because whatever operations we do, we need a special privileges to do those operations. So mainly repo privileges, we need all these privileges, and admin privileges we need. Okay, and then user privileges, delete repository. That's it. So as of now, these are our privileges are required. Just click on the generate token. So once you click on generate token, now token is got created. Just copy these tokens. So you create your own token. So for now, I'm just copying here. Okay. This is a token I'm trying to use. Okay. Now you just copy this token in this box. So how we got this box? After executing git push origin master, we got this box. So browser and device and token. So in the token section, I'm copying my token. Whatever token I've copied, just I copied here. Then click on the sign in. So once it is done, now it is trying to push our code. So you can see 100% it is done. So once it is done, now go to your repositories. And where is your repository? Go to your repositories. Sorry. Go to your repositories. And previously, we don't have any files in the OpenCart version 1.1, right? Now, if you open this, you can see all the files are pushed here. And I have seen commit also, commit message also. See, all the files are pushed into remote repository, right? So this is a first round of execution. So 6 steps. First, we have created a new repository. We provided the user information. We had added all the files to staging. Then we committed the code into local repository. Then we established the connection to the remote repository. Then we push the code into remote repository by using token. This is the workflow. Okay. So now let us see another round of execution. So from the second round onwards, you no need to execute all the commands. So by default, I'm using master branch. So for now, I'm not talking about branches and everything. Just look at the workflow. Everything I'm doing, everything in the master branch itself. Okay. So now let us see another round of execution. Suppose round 1 we have done. So round 2. Suppose next day. So first round, the new code, fresh code, first time you are doing. So we created a new repository, added user information, add the files and everything I have done. Now the second round, second day, let us say I have done some changes. Let us say in my test cases, I have added, let us assume they have added one more new test case. So I'm adding a new class. I'll name it as a search underscore 004 underscore search. Okay, this is the new class I have added. Let us assume I have added new test case. This I will implement later. Save the file. So one new test case I have added. Now also I will do some modifications. I will also do some modifications. So what are the modifications I will do is, I can go to, I can do whatever modification I want. So I can just go to some file and I'll do some modification. Okay, so log files are there, right? So I'm just deleting these log files. And also there are so many reports I've generated. So I'm also deleting all the reports. I don't need these. So I have done some changes in my project. You can insert a new file or delete file or update file, whatever you want, you can do it. So I have done some changes. Now these changes are not part of your local repository, which are not part of your remote repositories, right? The latest changes. Now I want to do the same. I want to do another round of execution. So now what we need to do now? Do we need to execute this command? No, because we already created the local repository. So do we need to execute the second command? No, because we already provided all information to the repository. So now directly we just add the files, commit the files, and even this is also not required because we already connected local repository with the remote repository. So we have to execute this command. Only 3 commands. What are they? Add, commit, push. Add, commit, push. Only 3 commands. So before doing that, I will also check the status. Okay, status. Git status. See this, what are the changes I have done? It will show you. So these are the files we have deleted. And this is the new class which we have created. So these are the red color means the red color representing these are not part of your indexing area, staging, and which are also not part of local. So now we need to do some changes. So now the first command directly you can say git add -a. All the files are added. Now again, one more time, git commit and -m commit method. This is my second commit. This is my second commit. So all the commits are done. So now we need to push those commits to the remote repository. How we can push? What is the command? Git push origin master. Okay, previously we already given the token, right? So it is automatically taken the token. So second time it will not ask you. So the new changes have already pushed into remote repository. Now we go back to the remote repository and see. So all our first commits are there. Now just refresh it. Now you can see these are the files. Log files I have deleted. So all the log files have got removed. No log files, only one log file. Go to the reports. Only one report I have. So currently I have only one report. So whatever the changes I have done in the second commit, you can see with the comment you can easily identify. With the comment you can easily identify what are the changes I have done in those particular file. So from the second round, you have to execute only 3 commands. Only 3 commands. So add all the files, commit message, git push origin master. Okay. So this is the task you have to do on day-to-day basis. As soon as you have done some modification in your project, you can create a new files or you can delete existing files or you can modify the existing files, whatever changes you have done here. At the end of the day, you have to make sure those changes should be part of your local repository. And also you need to make sure those changes should be part of your remote repository. Now Jenkins will pull the code from the remote repository and that will be executed. That is the next level. Okay, now I will show you one more step. So we have seen only one direction. can we get the reverse direction? For example, in the GitHub repository, not only by you, some other people also pushed the code in the same repository, right? Some other people also pushed the code in the same repository, but those files are not part of my workspace. Then how we can get it? So for example, let me show you this. Let us say this is my remote repository. So this is a tester 1, tester 2 committed their code. He pushed it, he also pushed it. Now whatever code I have pushed, that code is already there with me. But whatever the code he has pushed, that code is not there with me. I want to get that also. So that means we have to pull the code from the remote repository to local repository. So in the reverse direction, how we can pull the new code from, suppose already code is exist in the remote repository, but that I don't have that code. I can get that code, how it is possible. So let me show you. So go to the remote repository. So here directly I will do some changes, or I will add some new file, which is not part of our local repository. Okay. So you can add files here. You can directly upload files directly here also. It just works like a Google Drive. Okay. So I'm creating a new file. Okay. So here file name I'm giving for testing.txt, and this is a sample file. One single line I have created, and then I'm creating commit changes. So create test engine.xml commit changes. So now I have created a new file that is here, testing.txt. Let us assume this file is pushed by somebody else. Now this file is not part of our local repository, also not part of our workspace. So can we get that file here directly when I refresh? No, we don't have the testing.txt file. So I want to get that file here. So how we can do this is the same Git. We will execute one simple command that's called git pull. Just git pull. So git pull and specify the URL also. URL also we need to specify. So this is your remote repository URL, right? That we need to specify. Give one space and give the command. That's it. So this command will pull all the changes from repository. You can see 1+ means one file is got added. Now if you go back to the workspace and refresh your project, refresh, now you can see testing.txt is there. Now again, I'll do some modification here. See, previously there is only one line. Now I have added few more lines. I have added some modification. Now I'll save it. Now this change is not part of the local repository or remote repository, right? If I go back and see the remote repository, open the file. So this change is not updated. Only single line we have. Now how we can update the change again? Same commands we have to again one more time. What is that? Git add -a and again git commit -m. This is my third commit. Third commit, and then git push origin master, right? So just one command, add command, commit command, git push origin master. That's it. So this will push the code. So now if I go back and refresh your remote repository and open the file, previously there is only one line. Now another few lines we have updated. Okay. So this is how we can do multiple rounds. So we can add the files to staging, repository, local, and then remote repository. If there are any files in the remote repository, we can get those files into staging. Again, we can modify them. Again, we can push them into remote repository. So these are the activities every day we will do day-to-day basis. This is all for new repositories. This is all for new repositories. Suppose pull the files from remote repository. So what is the command? Git pull and repository URL. So whatever repository URL is here, so I'm just keeping the URL. Okay. So this is all process for the new project. So we have created the new repository and everything we have done newly. Suppose if you join a new company in the new project, so they already done some project and they already there in the remote repositories. So they will ask you to clone the repository and review it. Okay, suppose there is some project which is already created and they have already uploaded in the GitHub repository. Now, what they will ask you is get the clone repository, get that repository, get the project from the remote repository into your local system, and then you can review that project. So then how we will do? You are not going to create any new repository, anything. Already repositories exist in the remote repository that you want to clone it. That is called cloning process. Creating is different, cloning is different. Here we created the new repository. So now we need to clone the repository. How to clone it? Clone new repository to local system. So suppose this is a major use case. Most of the times, if you join in a new company, this will happen. Some new repository is already there in your GitHub. So I want to clone that repository into your local system. So how we can clone it? So for example, let's say, let's go to the remote. Let's go to my repositories. Okay, so there are so many repositories are there here. Okay, so there are so many repositories are there. Let us take one repository. So test repo is there. So now I want to clone this. So if I open this repository, so do we have any files in this? I don't have. I think there is only one file is there. Let us assume this is created by somebody else. This project is already there in the repository, but this project is not there in my local. So I want to clone this. So to clone this repository, we need to, they will provide the repository URL. So that we need to capture. So from where we will capture this URL is, you can just go to the code and here you can find the URL. So URL is must. So by taking the help of URL, you can clone it. How to clone? The command is git clone and specify the URL. So where you want to clone this project, there exactly you have to execute this command. So I'm closing my this git command prompt. So I want to clone the project somewhere in my C drive in automation. So here I will create a new folder, my project. Okay. So let me remove this. Yeah, now my project is there, right? This is the new. Here I want to clone. So here you open the GitHub repository. So go to show more options, GitHub bash. So open the git command prompt. We are not going to create any new repositories, nothing. Okay, just we have to clone the existing repository into local. So here just execute this command. So this is the URL of my remote repository. The command is simple, git clone. Git clone and repository URL. Quotations are optional. Even if you provide the quotations, no problem. So this repository is there in my remote website. That's not there in local. So if I execute this, it is trying to clone. So now we can see we got a repository. So once you get it, you can import this in your Eclipse and you can continue work on this. Okay. So this is how we can work with the Git commands. These are the basic commands. Pull command also can pull all the files like clone. Yes, but there is a difference. So pull we can use, suppose the project is already existed in the remote and also local in both the places. In those cases, we will prefer pull. Suppose the project is exist in the remote repository, but that is not there in the local. So I want to get that project into local repository. Then we will use clone only one time. Only one time we will clone it. So once you cloned, you will get a project, right? So from there onwards, we can use all other commands as usual. So git add, commit, push, these commands you can use as usual on the cloned project. Okay, there is a difference. So these are the basic commands. So everybody has understood so far the workflow, how we can achieve this from staging to working space to staging, then local repository, then remote repository. So this is a step-by-step process. So all the commands I have given very carefully. So creating the new repository, provide the user information, adding all files to staging, then commit the changes, then connect local repository with remote repository one time and push the code. Git push origin master. So these are the sequence of commands we have to execute. This is the basic stuff. And the same thing we can do by using Eclipse commands. In Eclipse itself, in the UI, the options are provided. All Git commands, whatever we have done using Git commands, all the commands, all the tasks, we can directly do within our Eclipse without using commands, without using this prompt. But it is very important to know some command from the Git. That's the reason I have explained everything through the Git commands. Okay. And in the next sessions, anyway, I will show you how we can do the same operations using Eclipse options. Eclipse, we have some options are provided. So by using those options, we can do the same activities. Okay, that we will do in the coming sessions. So if we come back to this process, we are able to send files to staging and local repository, and then we're able to push them into remote repository. At the same time, if there are any extra files in the remote repository, we will able to pull those files into your local repository. And also we have seen how to clone the new repository from remote repository to local repository. Okay, so this is the process. In case of some enhancement is necessary after commit, before push, what are the actions we have to take? So there are few more commands are there. Again, we have to execute some more commands, like fetch command is there, reset command is there. So by using those commands, we can get back those changes. Again, we can commit, we can recommit them. So I will provide all the list of commands. So later you guys can explore those commands. And when you come this particular concept, there is one question here, most important. Listen very carefully. I said there is only one remote repository for one project. Let's say there are multiple people are working here, here, and here. They're having their own code, right? And here there is one repository will be maintained for all the team members. So he will add 10 lines. He will add another 10 lines. He will add another 10 lines. All are totally different. Sometimes this code will be different. Sometimes there will be common lines will be there here, here, here. Sometimes when you create a page object classes, there will be common things. But once they added all the files into the remote repository directly, definitely there will be conflict, right? Definitely all the code once you integrated, definitely there will be complicated. Some common files will be there. Some common code will be there. Definitely there will be common duplications you can find. There will be conflicts, right? So to resolve the conflicts, what you will do is everybody will maintain their own branches. So the main branch name is called master branch. Default branch is master everywhere in the GitHub repository. Even in the Git also, the default branch name is master. So whatever the workflow we have done, everything we have done through master branch. We have added all the files to the staging, committed in the local repositories and pushed to the remote repository. Everything is happened directly in the master branch. So normally in the real time, what happens is everybody is having their own branch. So let's say this guy will have another branch. For example, let's say B1, and this guy is having B2. This one is B3. They will create their own branches. And whatever code they have created and committed, pushed, everything will happen within their own branch and within their own branch. And here also in the GitHub also, there is having one branch. So the same branches will be maintained here also. So you can say B1, B2, and B3. So whatever code you have done here, everything you will do within your own branches. So once you are pushed code your own branches, now these three branches will be merged into one single branch and copied into master branch. So these three branches will be merged into master branch. So at the time of merging, if there are any conflicts, so there itself we will resolve. This is called conflict resolution process. After merging, there will be some conflict. Those conflicts we can resolve inside the GitHub repository itself. And this process will be taken care by the senior people or GitHub admins. There will be a GitHub manager, specific role will be there. So their job is what? Once you pushed our code into individual branches, they will merge it. After merging, again, they will do some kind of review. Okay. And in that review, they will identify what are the common things are there, duplicates are there, what are the conflicts are there. they will identify, and accordingly they will modify it and finally merge it into master branch. So the master branch is always having final code and working code. That code should be up. That code should be working condition, and that particular code will be there in the master batch. Okay. So here I'm not going to teach any branching concept, merging, conflict. So these are advanced concept. I will share some of the videos which are already recorded, because at least we need to have two GitHub accounts. One is Git user, Git administrator. So the communication will happen between these people, because the GitHub will be maintained. These branches, main branch will be maintained by the admin, and these are all users. So if you have multiple accounts, you will able to simulate this kind of environment. So I already created some videos for advanced stuff along with some more commands. I will share those videos. The lengthy course is there. So you can go through those videos and try to understand the GitHub. So this is the basic stuff. Okay. So all Git command, not only the few commands I have explained today, other than this, almost 10 commands are there, 10 plus commands are there. All commands I have executed. So merging concept, resolving conflict, and fetch, pull request, and there are multiple concepts are there. So all concepts I have covered in those videos. You can go through them, you can understand. Okay, so at beginner level, this much is more than enough. Okay, so this part is covered. In the tomorrow session, I will show you how to install Jenkins and how we can run this GitHub project inside the Jenkins, and what are the configurations we can do inside the Jenkins. So that part we will see in the tomorrow session, and then we will finish it off. So that is a plan. Okay. So yes, once your GitHub is got created, so if anybody is having the GitHub URL, everybody can access. If I provide this URL to you, you can easily access my GitHub project, and also you can run my project in your Jenkins, because this is the global repository. So everybody is able to access. If I provide this URL to you, I put in the chat box. If you already have a GitHub account, you can just click on the link. You will able to access this project, because this is a remote or global repository. Everybody will able to access. That is the reason in future, if you do any projects or if you do any practices, try to keep everything in the GitHub repository itself, so that it will be tracked everything. Okay. Suppose after 1 year or 2, 3 years also, if you look back and see, all your stuff will be saved in the repository. And if I look at my repository, I created so many repositories from the last 3 to 4 years. You can see there are so much tasks. So whatever the task, whatever I have newly explored, everything I make sure I put it in the GitHub repository. So these are all my repositories. If you share that link to somebody else, they can look at your work and they can satisfy with that. Every repository is by default public. And if you make them as a private, you only can access it. Nobody else cannot access. Okay, so nobody else can access. Only you can access a repository if you create a private repository. And also, if you make it as a private repository, you cannot run that through Jenkins, because Jenkins is an external tool, right? Even Jenkins also cannot access your project. So better to make that as a public repository, so that Jenkins also we can access. Okay. So that's all for today's session. Just follow this step by step. I put all the stuff, and I will also upload the document. So Git installation document and Git commands. So these are the basic commands. So do practice this. And whatever activities we have done through commands, we can also achieve this using Eclipse options. Even in Eclipse also, the options are available. That is more easier than the commands, because the commands, in the sense, every time we have to remember, right? And Git is also we need to install. But if I don't want to install Git software, I don't want to execute the commands, still I can do them using UI options. So that I can show you in the coming session. We will do Cucumber project, right? So once we have done Cucumber project, so in that project, I will show you how we can do the same activity using Eclipse UI options. Okay. So that's all for today's session. Just practice these things for today. And tomorrow session, we will discuss about Jenkins concept. All right. So I'll stop here. We'll continue tomorrow.